Hi, so this is my 5th video on electricity. So, in this video we're going to find the electric field from a charged plate. So, let's say we have a positively charged plate with a uniform charge density called sigma. So sigma is the density of the charge on the plate, which is equal to the charge per area. And we want to find the electric field at a height h above this plate. So to do that, we're going to use Gauss's law. And so I've drawn a cylinder that goes through this surface, and it goes at a height h above the plate and at a height h under the plate. So that's what I've drawn in this diagram. And we're going to use it to find the electric field at a height h. So to do that, we're going to find the electric flux through this, and then we're going to use it to find the electric field. So the first thing we're going to do is find the electric flux coming out of the walls of the sphere. So the walls of a sphere have area elements like this on the wall, and then here's a little vector dA. And since this is a plate, the only charge will be coming from this part of the cylinder, which is on the plate. And the charge of that equals pi r squared. Pi r squared is just the radius of the cylinder times the charge density, sigma. That would give you the charge of this circle here, which is the only part of the plate that's giving charge in this cylinder. So pi r squared sigma is the charge. Remember that Gauss's law says the integral of the electric field dotted with dA equals the charge inside divided by epsilon naught. Well, E dot dA is always equal to 0 because dA will always be perpendicular to the electric field, because the electric field will be going through like this because it's a flat plate. So the electric field from a uniform charge density would look like this, and it's always perpendicular to this dA. Even if you go down here, the electric field is always perpendicular to dA on the sides of the cylinder. So that means that the electric flux going through there is equal to 0, and that also means that there's no electric field. So there's no electric field coming through the sides of the cylinder, but there is an electric field flux coming out of the top and bottom of the cylinder. So using Gauss's law, these are both the height h above and below, so that's why we can say this. So using Gauss's law, the integral of the electric field dot dA equals the charge inside divided by epsilon naught. We can do E times the integral of dA, because over here the area elements are always parallel to the electric field. So E dot dA, so the cosine of the angle between them is 1. So E dot dA is just the magnitude of E times the magnitude of dA. So E times the integral of dA equals the charge inside. Well, it's pi r squared sigma. Pi r squared sigma divided by epsilon naught. And the integral of dA is just the area. So the area that's on this cylinder is this area and this bottom circle's area. So that equals 2 pi r squared. So E times 2 pi r squared equals pi r squared sigma over epsilon naught. Then we can divide both sides by 2 pi r squared. And then we have that the electric field equals sigma over 2 epsilon naught. And as you can see, this doesn't depend on the height above the plate. That means that the electric field at any height above the plate is sigma over 2 epsilon naught. So that's pretty interesting. So that means that the electric field is always constant at any point, so it looks somewhat like this. So the electric field at any height above a positively charged plate, or any charged plate actually, equals the charge density divided by 2 epsilon naught. So let me go over what we did. Here's the plate. We drew a cylinder that goes through the plate, and it goes at a height h above and below the plate. And this is where it intersects the plate at a circle, and that circle has a charge pi r squared sigma, where r is the radius of the cylinder. And then we realized that the electric field coming out of the sides, like this, is 0, because the electric field is always pointing up. So that means the electric field coming out of the sides is 0. So the electric field coming out of the sides equals 0. And then we use Gauss's law to find the electric flux coming out of these two circles. And then we found that using that the electric field equals sigma over 2 epsilon naught. And it doesn't depend on the height above the charged plate. So that's what I wanted to go over in this video. Hope you like this video.